Okay, today we're going to talk about Java exceptions and runtime errors. We're going to first discuss why we need to understand exception handling and what happens when there is an exception in Java. We're going to discuss the exception handling classes that are currently in Java. We will also talk about how we add to that hierarchy by subclassing the extension classes. We will talk about the difference between unchecked and checked exceptions and how we deal with either type of exceptions. Then we will write custom exception classes ourselves. Now let's talk about why we need exception handling in the first place. Now, when you write your program, it's all good and well. You write the program, which is basically a set of instructions instructing the hardware what it is supposed to do. Okay? But then your program has to be run by users. Users might type in the wrong input. You might ask for a number, and the user might type in a string instead. Say you want to calculate someone's age. You ask them the day of birth and they put in a string. You could also run into a situation where your program tries to write to unallocated memory. For instance, you have an object which, while you were creating your program, you had its reference set to null. You forgot to instantiate the object. You could also have issues with trying to access a file. Files obviously could be deleted by someone from outside the program. Files could be on flash drives. Flash drives could be removed. So that can happen. There are also cases where you're trying to create an object but there's not enough memory. Perhaps there are other applications you're running on the computer, so the computer runs out of memory and cannot create the object. Now, these are just a sampling of various issues that could happen in the real world. Okay? There are lots more that could happen. For instance, your program is trying to send information over a network, but the network is not currently available. So there are lots and lots of events that can happen. And Java has a specific way of handling these events, which we will get to discuss very soon. And there is also a way for us to control how these events are handled. Okay? Because the default way in which these events are handled, which we will see an example of very soon, gives us something like a cryptic error message and then ends the program, or what you might know as it crashes the program. Okay, there will be times when we will be able to recover from the exceptional or error condition, and we will talk about how we would do that. And there will be times when we want to control what information is provided or whether that information is saved to, say, drive, so that we can be able to debug based on what is causing exceptions in our program. Okay? So we've switched over to Eclipse, and what we're going to do now is we are going to simulate an exception. We're going to simulate a divide by zero exception. Okay, this is a program that should run okay. Obviously, it's not going to show us any output, okay, when we run it, since I don't have a statement to print something out. But I am going to compile and run it nonetheless. Okay, so it compiled and ran. There's no issue with this program as it is. Okay, but now if I try to divide by 0, I am going to compile and run again. I get this exception message. Okay, it says exception in thread main. And what that means, what this means, is that the exception is in the main method. Okay, and then I am given the exception name, and then I am given a text string describing the exception. Okay, and it gives me the path, which is the package name, the class name, the method name, and it gives me the file name and a colon and the line number at which the exception happened. Now, in order for us to kind of discover a little more about what happened when this exception happened, I am going to do a print statement. Okay, and I'm going to change the 0 to something else, let's say 3, or let's say 1, okay, 5/1. And I am going to run this code, and it shows the result, which is 5, okay, and I'm going to put a 0 again so that we get the exception. Now, another thing that happened was, once this exception happened at this line, the program doesn't continue executing. It doesn't go to the next line to continue. It ends execution. Okay? So this is the default way Java handles exception. If an exception happens, and we haven't ourselves written some code to handle the exception, then what will happen is the default behavior is Java is going to end the program, exit the program, and we are going to get this printout, okay, which will tell us the details of the exception as well as a stack trace, which is, it will tell us within which method the exception happened, and if the method is being called by another method, it will tell us, it will give us a sequence of the methods we are within, okay, for us to understand the context of where the exception happened. Okay, now the next thing I am going to do is I am going to remove this line that gives, obviously, the exception. I'm going to put a 1 there, okay, and I'm going to add a new line of code, which, well, before I add the new line of code, let me execute what we currently have, and it gives a 5, okay. I'm going to add a new line of code that should help us understand what exactly Java does in the background when the Java virtual machine sees an exceptional condition, okay. What it does is it creates an object, okay, an object of type exception, okay. I am kind of going to simulate what it does, what the JVM does. It creates, let's say, new. The particular exception we were dealing with was, what's the name again? Was an arithmetic exception, okay. So I can simulate what Java does by creating the exception object myself. Okay, so I'm going to create a new arithmetic exception. Okay, and to have Java treat this arithmetic exception the same way it would if I did actually have an exceptional condition caused by, say, dividing by 0, I would throw this newly created exception object. Okay, I would use the throw keyword. Okay, and I am getting this error because this line of code will not be reached, because I am throwing an exception, and when that exception is thrown, the virtual machine will exit without getting to this line. So I'm going to comment out this print line, and I'm going to run this, and there you see something that looks very similar to what we had before. It gives us the thread name, main. It gives us the type of exception, and it gives us the path to the exception. Okay, you might also notice that it didn't give us a description of the exception. Well, I could create this new exception with a description if I wanted to. All I need to do is to pass a string, okay, and say description, and there you have the string, which in the previous case said divide by 0. Okay, so this is what Java does. When the virtual machine encounters an exceptional condition, it creates a new exception object, just as I have done here, but then it does that implicitly, and then it throws that object. Okay, and what that means is, on throwing the object, the virtual machine will look to see if we have written any code to handle the exception, and if we haven't, our program gets to end and we get this printout, and if we have, then the code that we have written gets executed. Okay, now let's take a look at the hierarchy of exception types that are available in Java. Okay, here we have a sampling of the exceptions that are available in Java, not all of them. Okay, now exceptions and errors are subclasses of the throwable class. Okay, when we use the throw statement, anything that comes after the throw statement has to be a subclass of throwable. Okay, now errors are special in the sense that we can't usually recover from them. Okay, we will talk about recovery very soon. Exceptions we can recover from. Okay, now there are lots of exceptions and they are grouped into different types. For instance, if we have exceptions that have to do with file access and file input output, then those are within the IO subclasses of IO exceptions. Okay, now you could have a class not found exception where at a runtime a particular file that you want to use cannot be found to be instantiated. Then we have runtime exception, and those would include like index out of bounds exception. A particular example would be an array index out of bounds exception. For instance, if you create an array of size 3 and then you try to access element 5 in that array, you will get an array index out of bound exception. There are null pointer exceptions. If you try to access an object but the pointer you are trying to use is null, meaning it's not really pointing to an actual object, you'll get this exception. There are illegal argument exceptions. For instance, if you try to convert something like a string, let's say you ask a user to input a number and you should try to convert that number from a string to an integer, and that conversion cannot be completed, say because they didn't enter a string that contains an actual number, then you'll get a number format exception. Now, the particular exception we just dealt with, which was an arithmetic exception, is not shown here. In fact, lots of exceptions are not shown in this diagram. This is just a sampling. Okay, now that would come somewhere here within the runtime exceptions. So I could draw a box and put arithmetic exception. Okay, great.